All right, guys, I wanted to review some of the questions I gave you in class and then also give you the answers to the probability quiz. All right, so this was the first question I gave you in class. This says there's a survey taken at Westland, and it's what's your favorite food, and the results are below. This many people said pizza, hamburgers, nachos, chili, and hot dogs. Based on those results, how many students would say they liked hamburgers? All right, and it gives us that there are 1,010 students in the school. So there's two ways to do this kind of problem. The first way would be to just use the probability, and that turns into a percent. So if I took, there were 12 students out of, and I counted up every one of these numbers, they surveyed 50 people. So that's 12 out of 50, which we could actually reduce that fraction. That's divided by 2 and get 6/25. So 6 out of 25 people said that they liked hamburgers. So if I wanted to make a prediction, I would take that number of the total students. So there are 1,010. So 6/25 times 1,010 would get you how many students you would expect to like hamburgers out of the whole school. Another way you could do it is you could take that same probability, 6/25, and form a proportion and just say how many students out of 1,010 students. And you would cross multiply. 25x is equal to 6,060, and you would solve from there. Both ways will get you the same answer. Next problem was choosing the best measure of central tendency. If you take this table, remember, instead of writing out 20,000 8 times, you could just do 20,000 times 8, 40,000 times 10, 60,000 times 5, and 200,000 times 2. And you get all that, you get a sum. You get the product of each, and then you're going to add each one of them up, and you get a total amount. So, this equals, we'll call it A, this will equal B, this will equal C, this will equal D. So you actually get those numbers, and when you add up A, B, C, and D, you're going to get the total amount, and you're going to divide it by how many houses we're looking at, which the frequency was 25, because there are 25 houses. And you get around, I don't have a calculator in front of me, but it's a 50 point something. So the question is, what measure of central tendency would you use? You have a mean equal to 50, about 50. You have a mode of 40,000, and again 50 meaning 50,000. And you have a median of 40,000. So in this case, what you would do is you would probably use the mode or the median. And the reason why is the two people that had houses in 200,000, that really made your mean go up a little bit. And the other reason is, if you think about it, there are, if you count, 18 houses that are all below 50,000. So if you were to say 50,000 where 18 were actually below that, you're not really giving an accurate representation. As opposed to a chart like this, when you find the mean, median, and mode, because there's really no one or two numbers that are higher than the others, because there's actually 8 different houses that are 100,000. In this case, the mean would be the best way to represent the data. All right, so now we're going to talk about, real quickly, your quiz that you got back and the answers to it. First one was probability to roll an even number or a 5, so you're only rolling once. There are 4 numbers out of 6 that are a 4 or a even number or a 5, because you got 2, 4, and 6, and then you also have the 5. That reduces to 2/3. Odds, remember, you're not doing the total, you're doing all the numbers that are 2 or below, so there are 2 numbers that are 2 or below, versus the numbers that aren't 2 or below, which is 2 out of 4, which reduces to 1/2. Next one, probability of getting the sum greater than a 10. Okay, so first of all, if you're rolling 2 dice, it's going to be 6 times 6, because there's 6 outcomes times the other 6 outcomes. There are 36 different outcomes you can have. One outcome would be rolling a 1 and a 2, or a 2 and a 1, or a 3 and a 1. Those are all different outcomes, but Total, there'll be 36. So what's the probability to get a sum greater than 10? So that'd be an 11 or a 12. Well, how can you get 11 or 12? You could roll a 5 and a 6 and a 5, or a 6 and a 6. Well, that's 3 out of the 36 outcomes, which reduces to 1/12, which is the probability. Probability of rolling the same two numbers. So there are 6 different ways you can do that. You could roll a 1 and a 1, 2 and a 2, and so on. And again, it's out of 36, which reduces to 1/6. Next one, probability of a 6 and a red. There's only 1 out of 6 on the dice that's a red. There's 1 out of 6 that's a 6. And the spinner I gave you in class had 2 out of the total 8 spots. And because we're doing two things, compound probability, you're going to multiply them and reduce. Probability less than a 3 would be a 2 or a 1, so that's 2 out of 6, times which ones were not yellow, 7 out of 8. You're going to multiply them because you're doing a compound probability, and then you're going to reduce. Last two, how many different combinations are possible if it is a four-number combination between 0 and 59. So what you had to remember is that's a permutation, because the order that you put the numbers in is important. There's 60 total numbers, and you're putting them into 4 spots. So that's 60 times 59 times 58 times 57. And last one, most of you got correct. You're going to use the fundamental counting principle and multiply 5 times 3 times 2.